Imagine a bridge so new that its concrete still carried the promise of progress, its steel still gleamed with national pride, and yet, within months of opening, it failed. On November 11, 2025, the Hongqi Bridge in western China collapsed, turning a symbol of modern engineering into twisted debris almost overnight. Bridges are designed to endure decades of stress, earthquakes, floods, and relentless traffic. They are not supposed to fall apart before the paint has even faded. So when this one did, it sent a shock far beyond the valley it spanned. This wasn't just a local accident or a routine infrastructure mishap. It was a warning sign, one that raises unsettling questions about speed, pressure, and the hidden costs of building faster than nature, geology, and physics might allow. At first glance, the story seems straightforward. A bridge collapsed, investigations were launched, and official explanations followed. But when you look closer, the Hongqi Bridge is not just any bridge. It was part of a larger push to transform China's western regions with massive infrastructure highways, tunnels, bridges, and most importantly, enormous downstream dam projects designed to control rivers, generate power, and fuel economic growth. In regions like this, everything is connected. The mountains dictate the rivers shape the soil, and the soil determines whether concrete stands firm or quietly begins to fail. When one structure gives way, it forces us to ask whether others are facing the same invisible stresses. This video is not about sensationalism, and it's not about pointing fingers at individual engineers or workers. Instead, it's about understanding systems. What happens when construction timelines are compressed? What risks emerge when projects are built in geologically complex regions under immense political and economic pressure? And most critically, what does the collapse of a bridge mean for much larger and far more dangerous structures, downstream structures that hold back billions of tons of water? We'll start by breaking down what the Hongqi Bridge was meant to represent and why its failure is so unusual. Then we'll explore the likely combination of factors that can lead to a collapse like this, from terrain and materials to oversight and design assumptions. Finally, we'll connect this single incident to the broader picture, China's megadam's long-term safety and the potential consequences if warning signs are ignored, because sometimes the most important stories in infrastructure aren't about what stands tall, but about what falls and why. The Hongqi Bridge was designed to be a statement of progress. Rising across a rugged valley in western China, it was meant to shorten travel times, connect remote regions, and symbolize the success of large-scale development in difficult terrain. Projects like this are not just about transportation. They are about integration, economic flow, and political messaging. A bridge here means access to markets, faster movement of goods, and tighter control over distant regions. That is why its completion was celebrated and its collapse was so disturbing. When a modern bridge fails within months of opening, engineers immediately know something is wrong at a fundamental level. These structures are built with multiple safety margins, designed to survive floods, temperature swings, and heavy loads for decades. Early failure suggests not gradual wear, but a serious flaw already present from the beginning. The collapse shocked locals, but it also alarmed planners and engineers nationwide. This was not an old, neglected structure. It was new, inspected, approved, and publicly endorsed. Its failure undermines confidence not just in one project, but in the process behind it. In western China, especially, infrastructure projects face enormous challenges: steep terrain, unstable rock layers, seasonal flooding, and seismic activity. Building here requires patience, extensive surveys, and constant monitoring. When timelines are aggressive, risks multiply quietly. The Hongqi Bridge became a case study overnight, a reminder that nature has not bent to schedules. The debris left behind was not just broken concrete and steel. It was a broken assumption that modern engineering alone can overcome every obstacle if pushed hard enough. Bridge collapses are rarely caused by a single mistake. Instead, they are usually the result of multiple weaknesses aligning at the wrong moment. In the case of the Hongqi Bridge, several risk factors stand out immediately. One of the biggest is geology. Western China is known for complex rock formations, fault lines, and unstable soil layers that can shift subtly over time. If foundation surveys underestimate these conditions, even a perfectly designed structure above ground can be doomed from below. Small movements in bedrock or soil saturation can introduce stresses that grow silently until failure becomes inevitable. Another factor is construction pressure. Large infrastructure programs often operate under tight deadlines, where speed is treated as success. When timelines compress, quality control can suffer. Materials may meet minimum standards rather than optimal ones, curing times may be shortened, and inspections may become procedural rather than critical. None of these choices alone causes collapse, but together, they erode safety margins. Environmental stress adds another layer. Heavy rainfall, rapid temperature changes, and erosion can accelerate weaknesses, especially in mountainous regions where water channels shift unpredictably. Design assumptions also matter. Engineers rely on models that predict loads, water flow, and ground behavior. But models are only as good as the data behind them. If conditions change or were misunderstood from the start, reality eventually exposes those gaps. The Hongqi Bridge likely didn't fail suddenly, it was probably failing slowly, invisibly, until one moment made it obvious. The collapse of a bridge is serious. The potential failure of a massive downstream dam is something else entirely. Dams operate on a completely different scale of risk. They don't just carry vehicles. They restrain enormous volumes of water, energy, and sediment. In regions like this, bridges, dams, and tunnels are connected through the same geological system. If the ground beneath a bridge shifts or weakens, the same forces may be acting on dam foundations, spillways, and retaining walls. That connection is what makes the Hongqi Bridge collapse so concerning. Dams depend heavily on stable foundations and predictable river behavior. But rivers in mountainous terrain are aggressive. They carry sediment that erodes structures, change course during floods, and exert pressure that increases year by year. If construction assumptions underestimate these forces, problems may not appear immediately. They can take years to surface until one extreme event pushes the system past its limit. The bridge collapse forces a hard question. If a relatively small structure showed vulnerability so quickly, how confident can planners be in much larger ones nearby? The stakes are enormous. A dam failure would not just disrupt transport, it would endanger entire communities downstream, damage ecosystems, and cause economic shock on a massive scale. That's why engineers treat warning signs seriously. In infrastructure, failures rarely come without hints. The Hongqi Bridge may be one such hint, suggesting that the region's challenges are deeper and more complex than planners assumed. Zooming out, the Hongqi Bridge collapse touches on a global issue, not just a national one: the tension between speed and resilience. China's infrastructure achievements are unprecedented in scale and pace, admired and studied worldwide. But speed always carries trade-offs. When success is measured by how fast something is built, long-term durability can become secondary. This doesn't mean corners are deliberately cut. It means systems are stretched to their limits, leaving little room for error. Public trust is another consequence. Infrastructure is invisible when it works and unforgettable when it fails. Each collapse chips away at confidence, raising doubts about oversight, transparency, and accountability. Internationally, incidents like this also affect perception. Other countries watching China's development model may begin asking whether rapid construction can truly be replicated without importing the same risks. The most important lesson may be the simplest one: physics cannot be rushed. Concrete needs time to cure, mountains need time to be understood. Rivers need to be respected. When those truths are ignored, structures may stand briefly but not reliably. The Hongqi Bridge may ultimately be remembered not just as a failure, but as a warning. A reminder that infrastructure is a promise made to the future, and breaking that promise can come at a very high cost. The collapse of the Hongqi Bridge leaves us with a question that goes far beyond one structure or one valley. Was this simply an unfortunate engineering failure, Or was it a signal that bigger risks are being overlooked in the race to build bigger and faster? Bridges, dams, and megaprojects are often celebrated as symbols of progress, but their true value is measured not on opening day, but decades later when they are still standing, still safe, and still serving the people who depend on them. What makes this story unsettling is not just what we know, but what we don't. Many of the most serious infrastructure failures begin quietly, hidden beneath the surface, long before the public ever sees a crack or a collapse. The Hongqi Bridge forces uncomfortable reflection. If a new bridge could fail so soon, how many other structures are carrying unseen stress, waiting for the right conditions to reveal their weaknesses? In the end, nature always has the final say. Mountains shift, rivers push back, and gravity never negotiates. No matter how advanced technology becomes, it cannot replace patience, transparency, and respect for physical limits. If this collapse leads to deeper scrutiny, better oversight, and a renewed focus on long-term safety, then it may still serve a purpose. But if it's dismissed as an isolated incident, the cost of that dismissal could be far higher than broken concrete and steel. Sometimes, the most important warning signs are the ones that arrive early before something even bigger goes wrong.
If you enjoyed this journey, make sure to subscribe to the channel so you never miss our next deep dive adventure. Don't forget to like the video and share your thoughts in the comments.